everyone, we're going to use the given coordinates to determine if triangle ABC is congruent to triangle DEF. And we're using the side, side, side postulate for triangles to determine congruency. So when we're looking at our congruency for the triangles, the first thing we're going to look at line segment AB with DE. So I'm going to look at these two with these two and use my distance formula. So the distance of AB equals the square root of 4 minus 1. I'm going to go this way. 4 minus 1 squared plus negative 3 minus 2 squared. And that gives me the square root of 3 squared plus negative 5 squared. So that's 25 plus 9, which equals the square root of 34. So now that should be equal to DE. So let's try the distance of DE. And what you get for that is 7 minus 4 squared plus 2 minus 7 squared. That's going to give you 3 squared plus negative 5 squared. So you can see these are the same. So that's good. Now we need to check BC with EF. So we're going to do the distance of BC equals the square root of, I'm doing BC. So that's going to be 2 minus 4 plus 5 minus a negative 3. So that's going to be 5 plus 3. That gives you negative 2 squared plus 8 squared. So that's 4 plus 64, which gives you the square root of 68. Now we're going to try EF. So the distance of the EF equals the square root of 5 minus 7 squared plus 10 minus 2 squared, and that gives you the square root of, again, negative 2 squared plus 8 squared, which gives you, again, square root of 68. And finally, we need to check AC with DF. So we're going to do AC with DF. So the distance of AC equals the square root of 5 minus 1. No. 2 minus 1 plus 5 minus 2 squared. So that gives you square root of 1 squared plus 3 squared gives you the square root of 10. Therefore, the distance of, let's see, DF should equal the same. So that's going to be 5 minus 4 squared plus 10 minus 7 squared. And that gives you the same thing, which equals the square root of 10. So since all these sides are congruent, that means the triangles are congruent by our side-side postulate. Okay, we have 3 more to do, and we're going to do number 5. There's your distance formula. It comes from the Pythagorean theorem, and we're checking sides, so our side postulate. So let's try AB with DE. So we have the distance of AB equals the square root of 4 minus 1 squared plus negative 3 minus 2 squared. And that gives us the square root of 3 squared. Oh, I'm doing the wrong one. All right, let's go back to this. Sorry about that. We're doing the second one. So this one right here, AB with DE. So AB is going to be square root of 4 minus 1 squared plus 0 minus 1 squared. And that gives you square root of 3 squared. Negative 1 squared is just 1. So that's going to be the square root of 10. Now let's try DE. And these are line segments. So that's going to be 6 minus 4 squared plus negative 6 minus a negative 5. So it's going to be plus 5 squared. So that's going to give you 2 squared plus negative 1 squared. And that gives you square root of 5. Since these don't match, that means the triangles are not congruent. So let's just write it out. Not congruent. The sides have to match. So for number 6, let's try that one. Hopefully we'll get the right one. So we're doing AB with DE first. So the distance of AB equals the square root of 5 minus 2 squared plus 1 minus a negative 2. So that's 1 plus 2 squared. And that's going to give you the square root of 3 squared plus 3 squared, which is the square root of 18. So now let's try DE. And we get the square root of, let's see, 10 minus 7 plus 8 minus 5. And that gives you 3 squared plus 3 squared, which is the same as square root of 18. So we have to move on, and we're going to do BC with EF. So the distance of BC equals 4 minus 5 squared plus 8 minus 1 squared. So that gives you negative 1 squared plus 7 squared. So that's 1 plus 49 square root of 50. So let's try the distance. These should all be lines of EF. And that gives you 9 minus 10 squared plus 13 minus 8 squared. That gives you negative 1 squared plus 5 squared. And that equals 1 plus 25 square root of 26. Since these two sides aren't congruent, the triangles are not congruent. Now I'm going to leave it to you to do the last one. I can tell you the answer is it is congruent. So try it out, and all the sides could be congruent. And so you could check with number 4, the first one we did. You have to check the distance of AB should equal the distance of DE, and the distance of BC should equal the distance of EF. Then you have to do AC with DF. So the distance of AC should equal the distance of DF. And they should be, because the answer is they are congruent. And that's it. Thank you. Have a nice day. Bye-bye.